Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome to my channel. So today I would like to present about the jobs for the statistical. So today we're going to learn about the descriptive data visualization in JASP, especially focusing on the basic plots. Before we jump into the software, let's first understand a little bit about the concept. So what is the descriptive data visualization? So descriptive data visualization, I would like to just explain about a little. Descriptive data visualization is basically a way to present data in visual forms, like graphs or plots, so that we can understand the data more easily instead of just looking at numbers. We can actually see the patterns, distributions, and relationships. So I think you guys know about the desk, descriptive statistics because it's just how we can do for looking the measures, of course, because the presentation of the raw data is very difficult for readers, of course, because I just tried to make a tutorial about the basic plots in descriptive data visualization using descriptive statistics. So I would like to tell about the basic first. So the descriptives have a summary, have a five. That is descriptive statistic that I will explain. Rank clock plots, time series descriptives, flex plot, and plot builder. Plot builder is like the beta, but I just would like to focus on the descriptive data visualization using descriptive statistics. Okay, so this is the descriptive statistics that we used it, and now we move to the basic plots. So this is the basic plots. Basic plots have many options that we can do, like distribution, correlation, interval, pie charts, dot plots, and QQ plots. Okay, first after before we start, you can open the JASP. After you open, you just the new data, and after that, we can click the analysis and move to descriptive and descriptive statistics. Okay, that's it. Next, we move to the basic plots. So this is my focus. So in the plot section, this is where you'll find the basic options, basic plots. So the first, we have the distributions plots. Okay, the distribution plots shows our data in the form of a histogram. The data is divided into separate groups called bins. Okay, so they divide that into the several groups. Okay, they call bins. Each bar represents how many data points fall into that group. Okay, so for for the example I will tell you later, that I'll just tell the explanation first. The tallest bar represents mode, which is the most frequent value in your dataset. In addition, there is usually a smooth curve displayed on top of the histogram, which represents the distributions of the data. If the shape of curve looks symmetrical, like a bell shape, it means your data is approximately normally distributed. However, if the curve is skewed to one side, it indicates that your data is not normally distributed. Okay, so for the example, I will put the number first. Like example, I will 70. Is this 70 again? This is 75. There is 80, and this is 85. Okay, that's enough. So let's move to the back again to the analysis. So this is the column. Okay, remember the column is your number. Then your column 1 is 70, column 2 is 72, column 3 is 75, column 4 80, and column 5 is 85. And now how we can see the draw? Okay, just drag this column to the variable. Okay, to the variable, and the column have been filled. Okay, now look at this. Look at this in the table, and don't forget on the distribution plots. Particularly is not zero number of observation because we need to move it again. Okay, let's move the column 2 and the column 3. Okay. Okay, this is the distribution plots. Why we can put a number? Because the number is not enough, so we need to fill more the number. Okay, let's go. I will put it, and I think the 85, 90, 90, and 100. And this is the 105, 110, 110, 110 again, 115, and 120. Okay, we have the third number. Okay, now let's move to the analysis. And waiting. This is the picture have do it. Okay, because the column was right now that I filled the number like here. So no, see, as you guys can see, this is the example of the distribution plots. And don't forget, if we need some like the line, we need to the checklist the display density, and we can have a line. So where is the in the middle? Yeah, in the middle. If you guys want to have a line, just checklist the display density. But if you guys don't want it, just turn off, and the line is gone. Once again, I will remember if the shape, if curve looks symmetrical, like a ball, like a bell shape, it means your data is approximately normally distributed. Okay. If the curve, okay, the curve like is symmetrical, like a bell shape, the line is going to up, and after that, in the middle was the up, then you want to move again forward, it will go down, just like a bell. So this is, if not, this is cute. This is called skewed. Why? Because this is the one side, guys. Okay, so our data is not it's not normally distributed. So that is the distribution plots. Okay, so okay, let's move to the interval plots. Before that, I will explain first. Interval plot displays the mean. Okay, mean is or average value. The average which is along with the interval, usually the confidence interval. So this plot does not only show the average, but also gives you an idea of how the precise that average is. For example, If the interval is narrow, it means the estimate is more precise. If it is wide, it means there is more variability in the data. Okay, so this is the interval plots. I will turn it on. Okay. So you guys can see the example of interval plots. Okay, interval plots. This plot is especially useful when you want to compare average between groups. So this is, guys, we have a fine column. So we have five example of the interval plots. So once again, interval plots means we search about the in the middle or the mean of the number. So you guys can see this is the number. You have 270, 175, 180, 280. Okay, sorry guys. In the column 4 and the column 1, the number 2. 85 to 85, 92, okay, 100 and more. So this is the in the middle. So you guys can see in the middle or the mean of the measures. So that is for how we can use the interval plots. So let's move to the quantile plot or QQ plot. Okay, before I turn it on, I have to explain to you all first. So let's talk about the QQ plot, which is this is the very important. QQ plot stands for quantile plot. Okay, it is used to check whether your data follows a normal distribution. In this plot, your data points are compared to a theoretical normal distributions and displayed as dots. Okay, as dots. To interpret it, you just need to look at the pattern of the dots. If the dots follow a straight diagonal line, it means your data is normally distributed. However, if the dots deviate far from the line, it means your data is not normally distributed. This is very important because many statistical tests, such as t-test and ANOVA, assume that the data is normally distributed. Okay, that's now to we have to turn it on. Okay, wait. So this is the QQ plot, guys. As you guys can see, I will repeat it again. You guys have to remember to interpret it. You just need to look at the pattern. So see you guys. So the dots are not deviate far from the line. So the data was not normally distributed. Okay, but if the dots on the line, it is the same with the line, like in the middle, of course. Just not only under the middle. No, it's not only in the middle. This, but on the line, the dots on the line. If the dots on the line, straight diagonal line, it means your data is normally distributed. So this is very important, of course, that we have the many statistical tests that such as I mentioned before, like t-test and ANOVA. Assume that the data is normally distributed. So that is for the QQ plots or quantile plots. And now for the last, the dot plots. Okay, so I will turn on the dot plots. Okay, I will explain. So the dot plots, the dot plot displays each data point as a dot. Each dot represents a single value. If a value appears more than once, the dots will be stacked on the top of each other. So the height of the stack shows how frequently that value occurs. This part is very useful for small data sets because it allows you to clearly see each individual data point. However, for large data sets, it may become too crowded. Okay. We can use dot plots if the data was like a small. So if we have used for the big data set, it will be not relevant with the dot plots. If you guys want to use for the big data sets, we can use for the interval, Kiki plots, and distributions. For the dot plots, it's just like we can use it for in the small data sets. Okay, that is for the example. All of the basic plots I can give you guys, and I give you two for the JASP tutorial for the basic plots on descriptive data visualizations. For the summary, okay, for the conclusion, distribution plots help you see the overall shape of the data. Okay, I remember again. If you guys want to add the line, just don't forget to checklist the display density. Okay. Oh yeah, I forget. Yes. The data it will be have at the and the line. Okay. And then remember again, if the for the distribution plots will be normal if you like a shape of a bell. Okay, remember the shape of a bell, like from under going to up, and after that it will be going down like that. And the interval plots show, okay, you guys, interval plots like this show the mean of the confidence and interval and the mean of the number. Okay. And for the Kiki plots, help you check whether the data is normally distributed. So I remember again, it is diagonally normal if the dots on the line. Okay. And the last is the dot plots. The dot plots allows you to see individual data points and their frequency. So this is relevant with the small data set. So yeah, I think that's all for today's tutorial on descriptive data visualization on the basic plots in JASP. I hope this video helps you understand the basic plots more clearly and makes it easier for you to use JASP in your analysis. Okay, thank you for watching, guys. So see you guys in the next video. Wassalamualaikum warahmatullahi wabarakatuh.